Now this idea, what happened, you have to start applying for any number of blocks. Let mu equal to 0.2. I applied a force F1 equal to say 2 Newton, F2 equal to 6 Newton. So this is rough. This is rough. So we have to calculate acceleration of blocks and the friction acting at all surfaces. So here, look at this. I brought two forces. Huh? Don't think that only one force will be there. Even I can apply force on all three blocks also. First calculate limiting frictions. Then you assume one situation and carry on. Okay, first limiting frictions, F1L. F1L should be equal to mu m1g 0.24 Newton. Similarly, F2L mu m1 plus m2 into g 0.25 10 Newton. What can be possible direction of friction? This will be, you look at block F2, that one. So I'll start with like this. I think this will be troublesome for you, sir. Here 2 Newton is acting. The friction should have been here. The friction should have been here backward. I'll solve it if I get F1 negative, the frictional force negative. Then I change the direction. Okay. So we should be ready for that also. By chance, if the friction comes negative, no, what you assumed is opposite to the actual direction. Because we are not very sure now in what direction that frictional force between block M1 and 2 will act here. So let's assume in one direction and carry on. What is the first assumption? We'll start with assumption 1. Always it's a practice that no slipping occurs. Assumption. No slipping occurs between the blocks. That's the first assumption. Then we'll assume that let A be the acceleration. What is the net force acting on system? F1 plus F2. Divided by M1 plus M2 plus M3. F1 F2 plus 6, 2 plus 3 plus 5. 8 by 10, 4 by 5. Now we'll cross check one by one. First, I'll check the F1, that one. So acceleration of the F1 plus F1 equal to M1. We know applied force F1, how much it is? 2 Newton. The frictional force we don't know. M1 is 2. This is 4 by 5. Anybody value? F1 will be?
Sir, minus 2 by 5.
Minus?
2 by 5.
2 by 5 or 0.4 Newton. What do you mean by negative? And it is less than F1L. This is very important. Check it now. So what we assumed friction was opposite. So I just brought this problem so that you can understand. So don't get scared. It's a negative answer. Something went wrong. No. Later on, in the end, we'll change the direction of friction acting on the blocks. I got less than F1L. So what I should conclude? No slipping occurs at M1, M2. No slipping therefore no slipping occurs at M1, M2. And now after this, I will go for the checking F2, that one. F2 equal to M3 into A. What is value of M3? 5. Acceleration is how much? 4 by 5. 4 meter, 4 Newton, I'm getting it. So which is less than F2L. So what does it mean? No slipping occurs at M2 and M3. So what we assumed is right or wrong now? Yes, it's right. Only the direction of friction will
Sir,
change.
so only the direction of friction is changing,
Friction,
sir.
you have to change it. Final. I'll conclude here now. So what is the conclusion now? So the conclusion, we are going to make it here. What is the conclusion? The conclusion will be like this. The friction, we assumed it, so it should be like this. F1, this F1. There's no change with this friction. And all will have same acceleration. No relative motion between the blocks. F1 and F2 are static. Okay, got the idea. So now you do one thing, change F1 4 Newton, F1 4 Newton, F2 or F1 2 Newton, let it be. F2 you make it 12 Newton. Verify as you increase the values, you check it. Okay, and I'll go for next set of problems. We'll discuss problems on friction on vertical surface. Friction on vertical surface. So here I'll keep a block. There's a wall. First, let me start with a small basic one. There's a block. That surface is rough.